Good afternoon. So this is my poster expanding the role of capillary electrospray ionization mass spectrometry in the area of metabolomics and biopharmaceutical analysis. So this poster shows some of the features and advantages of the CSI technology in a wide variety of applications, both proteomics and metabolomics. So what you see here is a description of the CESI sprayer, which is effectively a capillary electrophoresis connection to electrospray ionization mass spectrometry. So here you see the representation of a cross-section of the sprayer, which has a tube through the center of the capillary down through here, in which the analytes are separated based on their mass-to-charge ratio, with the spray section at the end here, which comes out into the mass spectrometer. Now the clever thing here is it's a sheathless setup, so that there is a very, very high resolution, ultra low flow rate on the separation, which then runs directly into the mass spectrometer. So this super low flow rate gives us exquisite sensitivity and minimal analyte competition. So the example applications we give here are both in proteomics and in metabolomics. One example down here shows a triptych digest of a common biopharmaceutical, trastuzumab, used to treat breast cancer. And what you see here is 100% sequence coverage of the protein, coupled with characterization of many of the common post-translational modifications, such as oxidation, glycosylation, deamidation, and pyroglutamate formation, all from one digest and one injection. Further up here, we have a different example, and this is looking at the plant metabolome. So in the examples we show here, the advantages of CESI-MS for the analysis of isobaric metabolites. So this example here shows three very closely related sugar phosphates, glucose 1-phosphate, fructose 1-phosphate, and glucose 6-phosphate, which would normally run out together on an LC-MS setup. Here on CESI you can see that we actually get separation, which is based partially on the PI, the isoelectric point of these molecules, and also on their shape. So this then gives us a better chance for the analysis and characterization by mass spectrometry, because these peaks can be then analyzed individually with minimal overlap of the charge envelopes. Similarly here we show examples of other metabolites, and a great example here also looking at citrate and isocitrate, again two isobaric compounds which are separated well for the same reasons. And then finally at the bottom here we show an example of separation of an intact protein. This again is a biopharmaceutical, separated and analyzed in our SCIEX BioPharma View software. So here we're able to separate intact proteins based on their charge. So we can now pick up charge variants on these proteins, things like deamidation and sialic acid content. So in conclusion then, we show here the ultra-low flow CSI MS connection, which allows us to have both very high sensitivity, minimal analyte competition, and gives us complementary separations, especially for some of these more challenging separations such as isobaric compounds and intact proteins.
Okay, thank you so much, Jim.
Pleasure.
Thank you.